Hey guys, so in today's discussion section, just about an hour ago, I gave this problem, and when I first gave the problem, I didn't quite realize that it was slightly trickier than I thought, but I decided we would end up, going through it anyway, and the solution that I came up with was a little bit convoluted. Uh, and someone brought up the question. So let me sort of outline the the solution of the problem, or at least the beginning, the approach, right? And show like what the obstacle is that we have to deal with, right? So what we would like to do to show that this lim sup over here is less than or equal to this product over here is to take an arbitrary convergent subsequence of this, right, and show that the limit is less than or equal to this product, okay? Now there's a little problem, okay? So here, let me start to write it out. So we have, so let S and K, T and K be a convergent subsequence of Sn, Tn. And what we would like to do is, oops, that the limit as k goes to infinity of Snk, Tnk is less than or equal to, if we call this L1 and L2, we want to show that this is less than or equal to L1, L2. If we do this, right, if we show that an arbitrary convergent subsequence has a limit less than or equal to L1, L2, that means the lim sup here is less than or equal to L1, L2, because the lim sup is the least upper bound on the subsequential limits, right? So here's the problem. Like naively, what we might want to say is, well, so naively, well, limit S and K is less than or equal to L1, and the limit of T and K is less than or equal to L2, right? But we can't do this, okay? Why can't we do this? It's because we never assumed that SNK and TNK each had limits, right? It's possible that SNK times TNK as a sequence has a limit, but neither SNK nor TNK themselves on their own has a limit, okay? So we cannot make this argument. So this poses something of a tricky challenge. And what I came up with to get around it was basically sort of this proof that, SNK is, that basically what I showed is that SNK times TNK is, so what I did, show SNK TNK is less than, or at least, or even like strictly less than L1, L2 plus epsilon for all but finitely many K for all epsilon greater than 0, right? So this shows, if we show this for all but finitely many K, that shows the limit here is less than or equal to this number. And then if since we showed that this limit is less than or equal to this number for all epsilon greater than 0, that means it's also less than or equal to L1, L2 itself, okay? This turns out to be somewhat, I mean, it's not horrible, but it's a bit convoluted. You can look at the discussion video and see to actually come up with, to use the bounds on SNK and TNK individually to enforce this bound involves a little bit of annoying algebra and some estimation. And there's something to be learned from looking at that, but there's a better way of doing this. And I think it's really beautiful. It hit me almost immediately after I ended the discussion. I was really hitting my head against the wall for not having thought of it earlier. But we're going to use something, one of the beautiful results that we've proved so far, okay, is, so here's the argument. Someone, and this was inspired by a student's question. So one of the students asked, well, why can't we just, assume, why can't we just focus our attention on these types of subsequences where SNK and TNK do converge, right? So the question is, okay, let me actually write this out. So why can't we only consider subsequences SNK, TNK, where SNK and TNK both converge, right? Another way of phrasing this question would be, the answer to this question basically would be the same as answering the question, are there subsequential limits, of SNK, TNK that do not arise as the limit of a subsequence SNK, TNK where SNK and TNK each converge. Okay, so the question is, right, because all we're trying to do is analyze the subsequential limits of SN-TN, right? We're just trying to analyze the subsequential limits of SN-TN, so we're looking at the subsequences, all the subsequences of SN-TN, right? And the question basically is like, well, if you consider any particular subsequential limit of SN-TN, sure, maybe it comes from one of these subsequences where SNK and TNK both diverge, right? Maybe it occurs as a limit of one of those subsequences, right? But maybe it also occurs as the limit of a subsequence where they both converge, right? So basically the question is like, are there subsequences of SN-TN where both of these diverge that have a limit for which there's no pair of convergent subsequences that have the same limit, okay? Because if that was true, then there would be no way to focus our attention on the situation where only SNK and TNK both converge. But it turns out that it's not true. It's actually possible to only consider the situation where SNK and TNK both converge. So let me show you how. It has to do with the Bolzano-Weierstrass theorem. So this is, I think, a beautiful example of how thinking hard about these questions basically leads you to this elegant argument, okay? Because let me try to describe how I ended up thinking of this. What I was trying to do was design in my head a sequence for which I could find some pair of subsequences to multiply together that gave me a particular subsequential limit that I could not get by taking two convergent subsequences and multiplying those together, right? That's what I was trying to do. And what I realized as I was trying to do that was that it was patently impossible because of the Bolzano-Weierstrass theorem, okay? So let me show you the argument, okay? Since it's so elegant, it's so beautiful. So since Sn, like remember Sn is bounded. So Snk is clearly bounded. There exists a convergent subsequence okay, sorry. So I had to make an edit to make sure that I was thinking about this correctly. But yeah, this argument does work. It's a little bit weird, but you'll see. So actually, for the ease of notation, let's actually call SNK TK. Okay, so let's write TK equals SNK. Okay, and let's say UK equals T. Oh, this is bad. Hold on. Let's use different. Okay, let's say AK and bk, okay? And then we have tnk, okay? So AK, remember, it's just our subsequence of the original, you know, SN, okay? And BK is our subsequence of the original TN. And SNK, well, really SNK times TNK was the subsequence of the original SNTN, but those both correspond to subsequences of SN and TN, okay? Now, since AK is bounded, right? Because it's just a subsequence of Sn, which is also bounded, right? There exists a convergent subsequence, which I'll call AKJ, okay? Okay, now consider the subsequence AKJ, BKJ of AKBK, right? Which, remember, we assumed, so we're assuming by our choice of SNK, TNK, AKBK literally is the same sequence here, right? So AKBK converges, right? So, and so since, so AKJ, BKJ converges, right? So that means since AKJ converges and AKJ, BKJ converges, that means BKJ also has to converge, right? At least if we're assuming that, you know, the limits are bigger than 0. So there might have to be some technical, there might have to be some other consideration, a slightly different argument for when one of these limits, if one of these limits happens to be 0, then, but you know, if one of the limits is 0, then this is kind of like trivially true anyway, right? So this has to converge, assuming that the two limits are both strictly positive, which is the only case that's actually interesting, okay? So BKJ converges as well, right? Now, if we say, so say AKJ converges to a number A, right? And say BKJ converges to B, right? Then clearly A is less than or equal to L1 and B is less than or equal to L2, right? Because AKJ is still a subsequence of Sn, right? And L1 is the lim sup of Sn. So the limit of any subsequence of Sn has to be less than or equal to L1. That's why A is less than or equal to L1. L2 is the lim sup of Tn, so that's why B has to be less than or equal to L2, right? Now, because this is true, that means that clearly AKJ, BKJ, let me move to a new page here. So AKJ, BKJ converges to AB, right? Which is less than or equal to L1, L2, right? And then, but, well, so AK, BK, right? Remember, we assumed that AK, BK converges. And we also found a subsequence of AK, BK that converges, right? Well, obviously, it has to converge because it's a subsequence of a convergent sequence, but they have to have the same limit, right? So AK, BK converges to the same limit, AB. So this is less than or equal to L1, L2 as well. But remember, this was just our original subsequence, SNK, TNK. So that means what we've shown is that the limit is less than or equal to L1, L2, which is exactly what we were trying to do. Okay, so let me just kind of recap a little bit here. All right. We took some convergent subsequence of SN, TN, okay? that convergent subsequence corresponds to two subsequences, one of Sn and one of Tn, which themselves may not converge, okay? So Snk and Tnk on their own might not converge. But then we found a subsequence of Snk, another subsequence, right, which does converge. And then we know that that corresponds to a convergent sequence of Tnk, okay? So if you take those two and multiply them, you get another subsequence of this, which now has the same limit here. It has the same limit as Snk, Tnk, right? But it comes from the product of two convergent subsequences instead of two divergent subsequences, right? AK and BK might diverge, but AKJ and BKJ have to converge on their own. So what we're saying, this is exactly answering the question of whether or not any of the subsequential limits of SN/Tn can come from the products of two divergent subsequences without also coming from a product of two convergent subsequences. What we're saying is that actually, if you take two divergent subsequences of SN/Tn, multiply them and get a convergent subsequence, you could have gotten a subsequence with the same limit by starting with two convergent subsequences anyway, right? So this is basically, right, this is, and remember, this here, there exists a convergent subsequence. This comes from the Bolzano-Weierstrass theorem. Okay, well. So I hope you understood this. I think it's beautiful. It's a much simpler argument that really capitalizes on the theory that we've been building in a much nicer way. Yeah, so I think this is a very worthwhile thing to understand.